Welcome to another lecture on Fuzzy Logic Systems. We often talk about membership function in the context of fuzzy sets. Let us discuss the properties and characteristics of membership function in more detail. Okay. As we all know that every element in a fuzzy set is associated with a degree of membership, which is a kind of strength of association, and it lies between 0 and 1. So this degree of membership is obtained with the help of a function which is known as a membership function. And whenever we design a fuzzy logic system for some real application, we have to design a membership function for that application. And it is designed with the help of expert knowledge or expert opinion. Suppose you have to design a fuzzy logic system for an air conditioner to control the room temperature. So you need the expert knowledge about normal room temperature, high temperature, low temperature, and all that. And this kind of knowledge you can achieve with the help of your experience. So that kind of experience or knowledge is required to develop the membership functions for the real applications. Okay. We can represent a membership function in graphical way as shown here. In this representation, the entire curve lies between 0 and 1. Okay, that is obvious because the degrees of membership always lie between 0 and 1. So it is having three important features: core, support, and boundary. So core represents that region in the universe for which degree of membership is 1. That is exactly 1. Or in other words, this portion of the membership function represents the elements with complete membership. Okay. And support represents all those elements which are having non-zero membership. Okay, that is, they may have complete membership or they may have partial membership also. So all such elements are represented by support. So you can observe that core is also the part of support, or in other words, core is a subset of support. On the other hand, boundary represents those elements which are having partial membership. Or you can say that boundary is support excluded core, or boundary is support minus core. So these are the three most important features of a membership function, and while designing membership functions we have to consider these characteristics. Okay. So depending on the application, membership function can take many forms as given here. It may be triangular. Here in this figure there are 3 membership functions and each is having a triangular shape. In such a membership function we have only one element with a particular maximum value. Okay. These are the membership functions with trapezoidal form. In this case, membership function is increasing in a random way or decreasing in a random way. Okay. Singleton membership functions are those membership functions which provide non-zero value to just one element. Or in other words, in a fuzzy set represented by a singleton membership function, there is only one element with non-zero membership function. Okay? And this is very famous bell shape. It is Gaussian membership function. Okay? So depending on the application, we can design a number of membership functions, and the way the elements in fuzzy sets take the degree of membership, we obtain different graphical representations, and we can name them accordingly. So based on the nature or characteristic of membership function, we can divide fuzzy sets in different types. A fuzzy set is known as normal fuzzy set if it contains at least one element with degree of membership 1, or we have at least one element in fuzzy set which is having complete membership. As shown in this figure, you can observe that we have one member here which is having complete membership and a number of elements in this region, okay, which are having complete membership of the fuzzy set. So this kind of fuzzy set is known as normal fuzzy set. Here we have some elements which are partial members and some other elements which are complete members of the fuzzy set. And the adjacent figure is representing a subnormal fuzzy set. In this fuzzy set, as you can observe from the figure, that the entire curve lies below this dotted line, and this dotted line is representing the complete membership. So you can say, you can observe that there is no member in the fuzzy set with complete membership. All the elements in this fuzzy set have partial membership. Okay, so this type of fuzzy set is known as subnormal fuzzy set. A fuzzy set is known as convex fuzzy set if its membership function is either strictly monotonically increasing or monotonically decreasing, as in this case. Okay, here this degree of membership is either increasing strictly or it is decreasing. So this type of membership function is known as convex fuzzy set. This type of fuzzy set is known as convex fuzzy set. And here in this adjacent figure, sometimes degree of membership is increasing, sometimes it is decreasing, then again increasing. So a kind of zigzag pattern is there. These type of fuzzy sets are known as convex fuzzy sets. Okay, and intersection of two convex fuzzy sets is also a convex fuzzy set. Okay, so fuzzy sets with the membership function was curve in graphical representation is either strictly monotonically increasing or monotonically decreasing is a convex fuzzy set. Otherwise, if we do not have this kind of pattern, membership function is increasing and decreasing in a random way, then it is a non-convex fuzzy set. Okay. Another important concept related to fuzzy sets is height. Height of a fuzzy set is the maximum degree of membership attained by any element in the fuzzy set. Okay. So for example, in this case, the maximum degree of maximum degree of membership for any element in this fuzzy set is 1. So height of this set is 1. In the same way, the maximum degree of membership obtained by elements in this set is 1. So height is also 1. In this case, the maximum degree of membership obtained by the elements in this fuzzy set is under 1. Okay, so height of this fuzzy set is smaller than 1. Okay, so if suppose roughly I say it is 0.8, so in this case height of the fuzzy set would be 0.8. Okay. So you can observe that if fuzzy set is a normal fuzzy set, then height is 1. If it is a subnormal fuzzy set, then height is under 1. Okay. The same thing is written here. The height of a normal fuzzy set is 1, and if it is a subnormal fuzzy set, then it is less than 1. Okay. Crossover point of a fuzzy set is a point X where degree of membership is 0.5, and there may be multiple crossover points in a fuzzy set. So in such case, the distance between two crossover points is known as bandwidth of the fuzzy set. Okay. Suppose we have two elements x1 and x2 with degree of membership 0.5. So the difference of these two elements represents the bandwidth of that fuzzy set. Okay. That's all for now. These are the references that you can follow for further studies on these concepts. Okay. Thank you.